Hello, General Chemistry. This is our second video on balancing equations. In our first, we covered the basics and went over the steps, and we did a basic problem. Today, we're going to add the complexity of what we do if we have unsplit polyatomic atoms. Well, the good part is the rules are essentially the same, but if you have unsplit polyatomic atoms, you can take a little bit of a shortcut. Step one, list all of the particles in the equation. So first we have this aluminum. And now we have what we've come here to discuss, our first polyatomic ion. We have nitrate right here, NO3, and we also have nitrate, NO3, over on this side of the equation. So if a polyatomic atom is seen on both sides of the equation, you can keep it together and you do not have to split it. You can count it as though it were one element, even though it isn't. So that's NO3. Hold on, these are all ready. So our nitrate is now something that we're going to count on both sides. Then we go here. This is hydrogen. So we've got a hydrogen. And we finally have SO4, which is another polyatomic ion. And as you can see, it is on both sides. So we can keep it together and count it as though it is one element. So we've listed all of our particles. Now we count them for each side. On this side, we have 1 aluminum, we have 3 nitrates, because it's in parentheses and this is the count, so 3 nitrates, we have 2 hydrogen, and we have 1 sulfate. Let's reformat these so that they are all the same size. Sorry. On the other side of the equation, we have, looks like 2 aluminum here. We have 1 nitrate here, we have 1 hydrogen, and we have 3 sulfates. So now we begin. First we follow our recommendations. First we look for metals. So aluminum is a metal and it's not balanced, so we might as well start there. We need more aluminum on the reactant side, so we can put a 2 here. I have to shrink the font of everything to make it fit, apparently. So we're going to put 2 aluminum. That will change this to a 2. So we have two aluminum. But now, look at this. We have nitrate. We have 3 nitrates, but we have 2 groups of 3. So now we have 6 nitrate on this side. All right? So we've balanced that, and we've made those changes. Aluminum is fixed. Now the next thing we can go to are polyatomic ions, and we have polyatomic ions now. So let's look at our NO3. We are way out of balance here. We need 6 polyatomic ions, 6 NO3 on this side. So if we put a 6 here, this will become a 6. And that hydrogen will also become a 6. Okay, so we've made that change. So we review, our metals are balanced. This polyatomic ion is balanced. However, we do not have this one balanced. So how do we do that? Well, this is on the reactant side that's low, so we need to add 3 more here. Doing that will make this 3. And now we have, this is a group of 2 hydrogen. And then if we have 3 of them, 3 groups of 2, that will give us 6 hydrogen. And there you have it. We are now balanced. So we can remove the blanks and finalize our answer. This reaction requires This reaction requires 2 aluminum nitrate, 3 hydrogen sulfate, 6, and it produces 6 nitric acid and 1 aluminum sulfate. I hope this helps. Struggle well.